Hey there, educator. Welcome to the show. I'm your host, Lanisha, and I'm all about helping educators make meaningful connections in math instruction. If you've ever attended one of my live professional development sessions, then you know how truly passionate I am about this teacher life. PD for the Soul is my space for providing professional development on the go, where you can take what you need and place the rest on the shelf for another day. New episodes drop every Sunday at 9 a.m. Eastern Standard Time. This is where we will dive into strategies, routines, and insights to help students build deeper understanding. And here's something new. Our monthly newsletter launches on March 1st. This will be your go-to spot for links to all resources we discuss on the podcast. I want you to have everything in one place. Plus, I'll share the books that will shape upcoming solo episodes in case you want to read along. But that's not all. The newsletter will also explore connections across domains and grade levels, because when we keep those connections at the core of our instruction, we give students the tools to make generalizations that make new concepts more accessible. So, hit subscribe, stay connected, and let's make math happen. See you in the episode. Hey educators, and welcome back to the podcast. I'm your host, Lanisha, and over the next couple of months, these solo episodes will be influenced by the Math Pact, Achieving Instructional Coherence Within and Across Grades, written by Bush, Karp, and Daugherty, and Visible Learning by Hattie, Fisher, and Frey. My goal in this series is twofold. First, I want to highlight how language that many of us brush off as insignificant is one of the culprits holding our students back. Second, I'd like you to make the commitment to do better, since at the conclusion of this series, you will know better. I often think about the children who were sacrificed during my first year of teaching. Do you ever do that? I had no clue what I was doing. There were strategies taught that I had no business teaching, and there was likely language used that had no real meaning. But when you know better, you do better, right? As much as I've grown and as much as I now know, I am still correcting my math language. I remember a colleague of mine giving me the side eye because I said, I prefer to plan lessons before just going into a classroom, whether it's mine or another teacher's. It's extremely challenging to unteach something that has been taught incorrectly. And sometimes our impulsiveness will have us taking shortcuts that won't result in any good for anybody. For that reason, I plan what I'm going to say. We often use words that reflect our own understanding, but those words don't always provide opportunities for understanding to those on the receiving end. Words matter, friends. And that's why we're talking about how consistency in our language builds math understanding. Before we dive into these words and phrases, let's talk about the Math Pact and why this conversation even matters. This book, written by Karen Karp, Barbara Daugherty, and Sarah Bush, is all about creating instructional coherence, meaning getting all of us on the same page with how we teach math across the grade levels. Because let's be real, a lot of the confusion our students experience isn't just because of the math itself. It's about the language we use to explain it. One of the biggest takeaways from the Math Pact is that words matter. The way we introduce mathematical terms, the consistency in our explanations, and even the small phrases we toss around can either build understanding or create barriers. We have a habit of giving the same concept multiple names, sometimes based on what it looks like rather than what's actually happening. Think about the strategy used for factoring in the 6th grade. The North Carolina standard calls it upside down division. Others say the ladder method or the upside down birthday cake. Sure, the latter two names might be catchy, but they don't reinforce the key idea, division. Instead of building understanding, we're creating unnecessary hurdles for students who now have to decode different terms for the same process. The book identifies 30 words and phrases that should be phased out by middle school because they no longer serve students well, or worse, they actually mislead them. It also challenges us as educators to be intentional with our language so we're setting students up for success in higher level math, rather than forcing them to unlearn and relearn concepts later. So in this episode, we're going to break down my top 10 expired phrases, unpack why they're problematic, and talk about better alternatives that promote real mathematical thinking. So go ahead, turn up the volume, let your family know you're off duty for the next 10 minutes, and let's get into it. In the episode, Maximizing Student Outcomes with the Final 3 Formative 5 Techniques, we discussed Show Me. This technique was a performance response by a student or group of students that extends and often deepens what might have been asked within an interview. It happens when we see something unique, something that catches our attention, or perhaps we're just curious about a student's thinking. Show Me allows us to see to what extent what has been taught has actually been learned. I love the distinction between show your steps and explain your thinking. Because for the longest time, I was guilty of telling students to show their steps without realizing how limiting that phrase actually is. When we say show your steps, what students often hear is follow this exact procedure I showed you. It puts the focus on mimicking a process rather than actually thinking through the problem. But when we shift to explaining your thinking, we open the door for more than one approach. It encourages students to articulate their reasoning, whether that's through words, models, diagrams, or equations. It also values different ways of solving a problem rather than just one correct method. Now, I get it. There are times when we need students to demonstrate a specific method because the standard calls for it. But even then, we can say something like, use a visual model to explain your thinking, or show how you're using common denominators to solve this problem. That way, we're still holding students accountable for the process, but we're also reinforcing the understanding behind it, rather than just having them blindly follow steps. It's a small shift in language, but it makes a huge difference in how students engage with the mathematics. Now, I'm not the only one who's been hearing this. I'm sure that when I say this, you guys are going to agree. We're always complaining about the lack of number sense, right? But friend, educator, I'm going to hold your hand when I say this. We are contributing to that lack of understanding. For one, we keep calling 0 a placeholder. 0 is a number. It can represent 0 ones, 0 tens, 0 hundreds, or 0 hundredths. It is not the smiley face that I've seen folks draw under the ones place when multiplying double-digit numbers. For 2, we have to start reading multi-digit numbers correctly. I asked a couple of my teacher friends, how do you read 0.2? They said 0.2. I asked them to read it again, emphasizing place value this time. They paused, wrinkled their faces, and then asked me what I meant. I responded with 2/10. They said, oh, calling numbers by their place value isn't just about precision, although that's very important. It reinforces magnitude, and it sets the stage for a deeper understanding of fractions. When we say 2/10 instead of 0.2, we're directly connecting decimals to fractions, making it easier for students to grasp how numbers relate to one another on the number line. See where I'm going with this? I'll be the first to admit, I used to do it too. I'd read the decimal as point because my students didn't know place value, and meeting them where they were helped me reach the goal faster. But quick doesn't always mean lasting. They may have pushed through in the moment, but in the long run, I did them a disservice. And when you know better, you do better. And that got me thinking, how many other words or phrases have we clung to just because they feel familiar? When I was in grade school, we called it borrowing and carrying when adding or subtracting double-digit numbers. It wasn't until I started teaching that I truly understood I was composing and decomposing groups of 10. I wonder if my teacher friends get annoyed when I say regrouping instead of borrowing. But honestly, I can't worry about that. Long-term comprehension is on the line. Speaking of outdated language that misleads understanding, we have to stop saying that we are reducing fractions. To reduce something means we are making it smaller in size, but when we simplify, we are creating equivalent fractions. The value doesn't change. Precision in language matters. And this is just one of many examples where the words we use can either clarify something or confuse everybody. And here's one that really grinds my gears because I see how much it confuses kids. Equations and expressions. They aren't the same thing, and they shouldn't be used interchangeably. An expression is a mathematical phrase that groups numbers, variables, and operators and stands for a single value or number. An equation, on the other hand, is a statement that shows equality between two expressions. That means what's on the right side, depending on the structure of the equation, isn't the answer. It represents the total or an equivalent value to what's on the left. And since we're already talking about equality, let's quickly distinguish between equal and equivalent. Equivalent means having equal value in different forms, while equal represents a direct relationship between two quantities, showing that they are the same in number, value, or measure. When we use these terms interchangeably, we blur an important distinction that students need to understand. Another common pitfall, the word plug. We use this when evaluating expressions. We hear it all the time, just plug in the number. But why did we move away from substituting? Maybe we assume that substitution is too complex, so we default to language that seems more accessible. In reality, our quick fixes might be creating more confusion. Instead of searching for alternative words, we could just lean in on visuals and models to help students truly grasp the concepts, because the kids are able. They can learn substitution. That brings me to a related issue. Expressions are simplified while equations are solved. These aren't interchangeable processes, and we need to be intentional about using the right terminology. The same goes for isolating the variable, something I've said countless times when working with students. But what does that really mean? Instead of emphasizing the move itself, we should be reinforcing the mathematical properties that justify it. And then there's canceling out. What is canceling? What does that even mean in a mathematical sense? It's vague, and depending on the context, it can mean different things, which only adds to the confusion. Instead of getting rid of terms or numbers, let's focus on the properties that create equivalent equations so students develop a deeper understanding rather than a memorized routine. And honestly, I've only scratched the surface when it comes to language we need to be more consistent with. There are so many other words and phrases that need to be adjusted or even deleted to eliminate unnecessary hurdles for students. John Hattie's Visible Learning for Mathematics highlights the power of language learning intentions and mathematical practices in shaping deep understanding. He emphasizes that intentionally introducing words in context and expanding their meaning across grade levels has a far greater impact than teaching students memory tricks like associating the U in numerator with up and the D in denominator with down. While those tricks might offer a quick fix, they don't build the conceptual foundation students need to truly grasp mathematical relationships. Instead of relying on shortcuts, we should focus on reinforcing precise, meaningful language to support long-term understanding. And there you have it, 10 math language shifts that will help build better mathematical understanding for our students. And this is just the start. There are many more words and phrases that need to be revised or removed altogether. Here's my challenge to you. Pick one term or phrase from today's episode and commit to changing the way you use it in your classroom. Reflect on your math language this week, because when we know better, you guys know the rest. We do better. If you found today's episode helpful, make sure you follow, leave a review, and share it with a colleague. And if you want to keep this conversation going, join me on Instagram or TikTok, where we'll be breaking this down further. As always, thank you so much for tuning in to PD for the Soul. Keep making math happen, and I'll see you next time.